Good afternoon. I thought that I would share this video to sort of express my understanding of independent, dependent, and operationalized variables. Uh, Maybe it might benefit some people, so I thought I'd share it. But before we begin, I just want to preface to say I'm not a TA, I'm not an SI, and uh, my perspective on this in no way represents the perspective of the instructor or the university. So, at any rate, let's go through a similar exercise to what we did the other day in class and try to understand what each type of variable means. So let's look at this hypothesis, which is completely ridiculous, but it's testable, which is people who have a preference for tuna sandwiches have a better understanding of quantum physics. So what the idea here is if you have an individual who likes tuna sandwiches, they will be better prepared to explain quantum physics, basically. So, what's the independent variable and what's the dependent variable first off? You always start with those before you operationalize. So, the independent variable, so the thing that changes is sort of feelings towards tuna sandwiches. So, it's going to be, let me just increase the size of the brush here. It's going to be preference for tuna sandwich. And you can sort of imagine a spectrum here, and this is what we're going to expect, is that this dude is crazy for sandwiches and this guy doesn't really care about them at all, and people who are more in this area are going to be better at quantum physics, and people who are sort of here are not going to be as good as quantum physics if our hypothesis is correct. So you can basically have the two states, the I like them or I don't like them, and understanding of quantum physics will depend upon that. So the dependent variable, as we just sort of stumbled upon, will be understanding of quantum physics. Okay, so that's the easy part. That's sort of, you take any hypothesis and you say that the independent variable, so something that we change or that differs, maybe we don't manipulate it, but it differs, will affect something else, the dependent variable. But there's a problem, and you might have already seen it, and that problem is that how do we measure preference for tuna sandwiches? Or how do we measure feelings toward a political candidate, or perspective, positive or negative feelings towards something. You have to operationalize your independent variable, which means you have to have some sort of measurable way to figure out where on that 0 to 10 scale they'll be. So in my case, if I'm designing this study, I'm going to say, let's design a survey, perhaps, okay? So let's have a survey, and so they're going to have this survey, okay? And this is going to be your preference of tuna sandwiches, and there's going to be some questions over here. How do you like them? How often do you eat them? What's your favorite type of tuna? Whatever. And then there's going to be, or maybe more easy to understand would be, how much do you like tuna? How much do you like bread? How much do you like mayonnaise? How much do you like tuna sandwiches? On a scale of 1 to 10, 10 being very frequent or 0 being not frequent at all, how often do you eat tuna fish sandwiches? And so they'll give scores, okay? So 1, 2, 3, 4, 5, or whatever. So each question might have a score, and then after they fill out the survey, you as the researcher are going to pull out this total number and say if there are 10 questions, it'll go from 0 to 50. So if someone answered around the 50, you can pretty accurately say this person probably likes tuna sandwiches. So what you've done is you've operationalized your independent variable. You have, in effect, given yourself a meaningful way to determine the state of your independent variable, which is liking or dislike in this case, or in the case of what we were talking about in class. So my group's example was interest or disinterest in mathematics. You'd give them a survey like this and sort of figure that out. So the operational definition will be, so the operational definition of the independent variable is score on a survey measuring preference for tuna sandwich. Right? So that's sort of, you can think of it as, you know, it's operational because you can actually perform operations with this. You can take this, you know, this number, this score, and assign, you know, groups of people who scored in certain score bands. You can look at the data. You can actually work with this. This is the operational, workable, practical definition of the independent variable, as opposed to the sort of abstract concept of what is preference for tuna sandwiches. So same thing for the dependent variable. How are we going to measure quantum physics? Understanding of quantum physics. So what we might do, and perhaps you've already come to this conclusion, is that we're just going to design, so we'll have a score on an exam over quantum physics. So by operationalizing both of those things, now we can say, okay, a score of 50 on the preference for tuna sandwich survey correlates to a higher score on the physics. So as tuna sandwich preference score increases, understanding of quantum physics score also increases, or maybe the trend doesn't hold, or as tuna sandwich score increases, there's no trend in the quantum physics, and you'd know that this hypothesis is a complete load of garbage, which it is pretty much. And I'm sorry, I should have checked for that, but what I'd said here is 0 to 50, but that should still make sense. So I hope that sort of helps clarify what an operational definition is. It's just your working concept. What do you actually call, how do you practically measure your independent and dependent variables? And once again, this is just my perspective. This is how I have this sort of set up in my mind. I hope it helped. If it confused you, just forget everything about this video and, you know, go back to the textbook, go back to the faculty, and you'll get it. So I hope it was of benefit. If you have questions, please let me know.